This is the 4-3 review. Calculators are allowed, though you won't need it in this particular problem. The goal is to find the value of a given specific criteria. So this is actually two different problems, but they both kind of go back to that same definition of f of x. So if we look at part A, we want f to have a local minimum at x equals 5. So in order to determine what this coefficient of the x squared will be, we need to know what happens when we have a local min. Anytime you have a local min or a local max, it must occur at the location where the derivative is 0 or undefined. So for part A, we will know that plugging 5 into the derivative will have to either be 0 or undefined, because we've got a local extreme value, so it had to occur at a critical value. So looking at f prime, we can see that it's a polynomial. Remember, a is a constant, so you just move through it. And we know that if we evaluate that now at 5, then we had better get a 0 out. So 5 cubed, that's 125 times 4 gives me 500, plus 10a has to be 0. So if I isolate a, I end up getting negative 50. So to look at part B now, different problem. This time we have an inflection point. An inflection point is going to occur when the second derivative is 0. So that means when we plug 2 into the second derivative, we got 0. I guess we could also put undefined, but since we're just dealing with polynomials, the undefined isn't going to happen. So I already have the first derivative here that I took in part A, so I can take the second derivative by looking at that one, and I'll get a 12x squared plus a 2a. So now we know that if I plug in a 2, that'd be a 12 times a 4 is a 48 plus a 2a. I should get a 0. So that means my a would be a negative 24. And we're done.